All right, so here's the last example that I'm going to present to you for solving quadratic equations using the quadratic formula. Of course, the examples I've provided are non-exhaustive. If you've noticed, we have had a defined value for A, B, and C for our quadratic formula. There are quadratic equations out there, that have a middle term missing. And guess what? You can still use the quadratic formula to solve. You just would use a 0 for your B because it's missing, or they don't have the constant term, and so in that case you would use a 0 for your C. So again, this is not an exhaustive list of examples, but these are enough examples to help you with that homework and move you through your homework. So thankfully for us, this example is already set up, good to go. We've got it set equal to 0. It is in that standard form. We go square, linear, constant, so we're good to go. Let's move over here and just define what those values that we're going to be using in our quadratic formula. So A is 2, B is -3, so we're going to really watch out on our opposite of B when we get into that equation, and C is -2. So we do take the signs on those terms. So we've returned back to our x equals form because we're dealing with a variable of x. So x equals, again, the opposite of -3 is +3, plus or minus, square root, -3 squared, so I'm going to really use those parentheses, -4 times 2 times -2. All divided by 2 times 2. So now you know, here comes the work. The real work of that quadratic formula is in our simplifying. So 3 plus or minus square root, all divided by 4, because 2 times 2 is 4. I can do that. So -3 squared, and again, I'm using those parentheses, so it's exactly how I wrote it. I'm going to type it. So that's why it's really important, because that happens a lot, to use those parentheses appropriately. So I'm going to put in a 25 underneath that radical symbol. So something interesting is going to happen in this that did not happen before. So as always, at this point, we're checking to see, is this the actual simplified form, or will we reduce, or, will our work reduce further? So we're checking with that square root of 25, and hopefully your brain's telling you, yeah, something definitely different is going to happen. This 25 is a perfect square. So this time, 3 plus or minus, I will replace that square root of 25 with its equivalent value of 5, because the square root of 25 is 5. And then I get to divide by 4. So this is definitely something that did not happen in our any of the previous examples. So if you notice, we no longer have a radical symbol in our answers, in our solutions. And with the disappearance of that radical symbol means that our solutions are no longer irrational numbers. They're actually going to be rational numbers. So in this case, it's going to be really important for us to split our two solutions to simplify them further. So we're going to come over here and we're going to do our work with x equals 3 plus 5 divided by 4, and x equals 3 minus 5 divided by 4. And we couldn't, when we separated out before, this last piece still had a radical symbol on it. So in order to write in exact form, we had to leave it with that radical symbol. Because remember, when you add and subtract, and it involves a radical, we can only add and subtract with like radicals, which means that the index on the radical has to be the same as well as the radicand. So we couldn't do anything on those examples before to simplify any further. But we can in these examples, because these are all rational numbers. You could even refer to them, if you wanted to, as integers. So in that case, they do simplify because I can do 3 plus 5. 3 plus 5 is 8. It's 8 divided by 4. So this first solution tells me that x has a value of 2. So when x has a value of 2, this equation will have a value of 0. And then this one over here, 3 minus 5, that's a negative 2 divided by 4. And if you want to use your calculator to support, go ahead. And then negative 2/4, we've already seen that reduction. That is negative 1/2. So we're also saying when x has a value of negative 1/2, this equation will have a value of 0. So the quadratic formula cannot only be used to find irrational solutions for a quadratic equation. It can be used to find rational solutions to a quadratic equation. So in closing, if you want to solve any quadratic equation, you can use the quadratic formula to solve that quadratic equation. And that's what makes that quadratic formula so powerful, right? Factoring was limited to, solving by factoring is limited to those polynomials that we can factor over the integers, whereas the quadratic formula has no limitations for solving quadratic equations. So when we see these solutions 2 and negative 1/2, that is an indication that we could have actually factored to solve here. We would have had to use our AC method, but no big deal. So if you start to see solutions like this pop up for your quadratic formula, you know that that's okay. Quadratic formula can be used to find rational solutions as well as irrational solutions. But when you notice that your radical symbol disappears, then you know for sure you've got to split that plus and minus solution out to actually work down to that reduced value of your answer. And that's all that there is for 7.4.